Hi, in this video we're going to be talking about pyramids. So a pyramid is a polyhedron with one base and several lateral faces that are all triangles. So it could look something like these two. So we've got a base here that is a square, quadrilateral, and it's got four triangles that go around it. This one has one, two, three, four, five, six sides, so it's a hexagon, and it's got triangles all the way around it. So the base can be any polygon. All the triangles meet at a common vertex. So you can see that all the triangles here meet up at the top. Here, all the triangles are meeting up at the top of that thing. And the number of triangles equals the number of the sides of the base. So we got a triangle on each side. The altitude is the height of that pyramid. So going from the center of the bottom up to the top, that is the height of that pyramid. Or from the center of this quadrilateral up to the top, that 72 is the height of that pyramid. Then there's a separate thing, which is a slant height. The idea of a slant height doesn't go through the pyramid, it just sort of follows along the outside of it in order to figure out what the height of that pyramid would be. Using that slant height is important for finding the surface area of a pyramid. So that's this L right here. But it's not used when finding the volume of that pyramid, which is this formula right here. So let's try it out. So to find the surface area, as I just said, we need to figure out what the slant height of the pyramid is. Sometimes they tell us it. These two examples that I'm going to do, I don't have that. So I have to find the slant height. And that slant height comes from a little right triangle that's over here. So to do that, we have to use the Pythagorean theorem. So the slant height, that L squared, is going to equal the height of that pyramid. So h squared plus whatever the distance to the edge is. So I don't know, we'll just call that b squared because why not? So our L squared in this case is going to equal our h squared. So that's 5 squared plus this 5 square roots of 3 centimeters. 5 squared, so 3 centimeters squared. That is going to give us our slant height. So that equals 25 plus, when we square both of these things, we get 25 plus, sorry, not plus, times the square root of 3 squared, which is just 3. So L squared equals 25 plus 75. So L squared equals 100. Meaning that L is 10. So that is the slant height of our shape. So our surface area of this pyramid is going to be N, which is the number of sides on that base, times a half, times B, which is the base of that triangle. So how long we have right here, that's our B, times our slant height L, plus the area of our base. So the number of sides that we've got is 6 times a half. Our B, that B right here, is 10 times, we just found our slant height, which was also 10. Not always going to be the same, just a coincidence that time. Plus the area of our base. So the area of that base, B, we're going to have to do that 1/2 of the apothem times our perimeter. So that's half of our apothem, which is 5 square roots of 3. And our perimeter, we got 1, 2, 3, 4, 5, 6 tens that go around the outside. So 6 times 10. So that equals, let's see, 6 times 10 is 60. Half of that is 30 times 5 square roots of 3. So that's going to be 150 square roots of 3 for our B. All right, so we just need to do a little bit of cleaning up on that. So our surface area is going to be half of 6, which is 3, times 10, which is 30. And then 30 times another 10 will be 300 plus our 150 square roots of 3. And this is going to be centimeters squared. So there is our surface area. To find our volume, we got a much simpler formula. Our volume is just going to be 1/3 times our base times our height of our pyramid. Now, fortunately, we already found our base right there. So our volume equals 1/3 the area of our base, which was 150 square roots of 3, times the height of our pyramid, which is this 5 right here. How tall is that pyramid? We're not using the slant height. It's got this H instead of the L that we use for our slant height. So that's 5. So that means our volume, 1/3 of 150 is 50 times 5. So that's 250 square roots of 3 centimeters cubed. Volume is always given in cubic units. Let's do one more example, just make sure we got it. So in this example here, we first want to find that slant height, which was our good old Pythagorean theorem. And you can even do it in the old c squared equals a squared plus b squared. If you don't want to do it in this format, it'll work just the same. So our slant height, that is our L squared, equals our A and our B. So that's partly the height of the pyramid, which is 72 squared, plus our B squared, going from the center to the edge. So since this is 30, all of this would be 30. We just want half of that. So this should be 15. 15 squared. So L squared equals 5409. So that means L equals the square root of that. Now that doesn't square root, so we're just going to leave it as the square root of 5409. It's going to make my surface area calculations look a little messy, but what are you going to do? Sometimes we get messy numbers. So our surface area equals our same formula from up there. So I'm going to cheat a little bit. I'm not going to rewrite it just to save space. Our number of sides, which is 4, times 1/2 times the base of our triangle. So the base of our triangle right here is 30 times our slant height that we just found, which was 5409, the square root of 5409, plus the area of our base, which I haven't found yet, so I better find that. So B equals 30 by 30, so 30 times 30, which equals, well, at least that's nice, 900. So that makes our surface area, let's see, half of 4 is 2 times 30 is 60 square roots of 5409 plus 900. That's just going to be done right there. When we find our volume, it's going to be that 1/3 times our base. Area of our base is still 900. And then multiplied by our height of our pyramid, not the slant height, so not this 5409, just from the center to the top, which is 72. 300 times 72 is going to be 21,600 meters cubed. Meters cubed. Oh, and I forgot units for the last one. Should be meters squared. Oops. Whoopsie. And that is our volume and surface area for those pyramids. Now, this example, it's actually kind of cool. They actually gave us the slant height right away. So L, we already know, is 15. We know some other stuff about it. We know that n, the number of sides that we've got on this one, is 4, because we got 4 sides on the bottom. We know the b, the base of our triangle, is 18. We can find the area of the base as 18 squared. So 18 squared is 324. However, this one does not give us the height of that pyramid. So we're going to have to do a little bit of work when we go after the volume. But our surface area, for once, is going to be kind of straightforward. So our surface area is, and I don't have it right up above, so I am going to write it out this time. So 1/2 b times L plus the area of our base. So our number of sides is 4 times 1/2. Our base is 18. And our L, because they gave it to us so nicely, is 15. Plus our B, which is 324, the area of the base of that pyramid. So we've got 2 times 18 times 15. So that's 540. Plus that 324. So our surface area is going to be 540 plus 322, which is 864 feet squared. Cool. So we've got a nice surface area. When we go after the volume, however, our volume requires 1/3, fine, area of the base, fine, but we need the height of this thing, not the slant height. We only got the slant height this time, so we got to just figure that out. So our height is going to be right here, and it's going to connect to our slant height. So we should be able to find it by doing c squared equals a squared plus b squared. Good old Pythagorean theorem. Our slant height here is 15, so 15 squared equals the height that we're looking for, h squared, plus this base. So this base should be half of our 18, which is 9, so 9 squared. So 15 squared is 225, and 9 squared is 81. So we got to subtract that 81 from both sides. So 225 minus 81 is 144. So that means h equals 12. So we got to plug that over in here for our h. So we got 12. Our base is that 324. And we keep that 1/3. 324, I know if I divide that by 3, I get 108 times 12. So our volume equals 1296 feet cubed. Just kind of plugging all that stuff into our calculator. So we got our volume and our surface area. Great. All right, so in this example, I kind of jumped ahead and did a couple things. I figured out what the slant height was using a similar process that we've done before. I know the base of this pyramid is going to be B. The height of my pyramid is going to be 4. I've got 4 sides going around this pyramid, and the area of this base of the pyramid is 36. In order to figure out the surface area and volume of the composite figure, and this is the thing I really wanted to talk about, is this sort of total equals parts stuff for this shape. So the parts of this figure seem to be 2 pyramids stacked on top of each other. So there are 2 pyramids. Now I'm going to go after volume first again because volume is a little bit easier to do. So our volume is going to just be 2 times what our area of our pyramids would be. So it would be 1/3 times our B times our height of that pyramid. So that's pretty easy to do. So that is 2 1/3. Our base I found over here, so that's this shape in the middle, 6 times 6, 36, times the height of our pyramid. And the height of our pyramid is right here. They told us that was 4, so I stick a 4 right there. So finding that volume is as simple at this point as just plugging all that into our calculator, and we get 96 meters cubed. When we do the surface area for this shape, we do want to do the two pyramids, but rather than just doing those pyramids, we want no bases. So we want two of those pyramids, but no bases for those things because those two bases are inside of that shape. We just want the outer parts. So we're just not going to use our normal plus b on the end of that thing. We'll do our surface area is 2, and we're going to follow our regular formula of n times a half times our b times our L, but then I'm not going to include that normal plus b. That goes away because we don't want to include it in the surface area of this composite figure because this figure in the middle is not being included. So don't include it here. So that's going to equal 2 times our number of sides, which is 4. No. Yeah, 4 times a half times the base of one of the triangles, so that is 6, times our lateral area, our our slant height, that's what I'm trying to say, which was 5. So we're finding our regular surface area, but we're not including the bases because they're overlapping on the inside, and we just don't want the stuff that's on the inside of the shape. We just want outside of the shape. So our surface area is just all that typed into our calculator, which is 120 meters squared. That is it for finding surface area and volumes for pyramids. Keep in mind the difference between this lateral of the slant height and the actual height of the pyramid. The actual height of the pyramid goes from the top to the middle, while the slant height of the pyramid goes from the top to the outer edge of that pyramid. So slant height versus the regular height or altitude of a pyramid. Thanks for watching. Bye bye.